Today we are solving ISS 2021 paper 2 question number 40. A random sample of size is taken from normal with the unknown mean theta and variance 100 and probability of accepting H0 when H1 is to 0.01 means the type 2 error, and if the critical region of size 0.05 means the type 1 error is used testing theta not null hypothesis is theta is equal to 90 against H1 theta is equal to 100 means simple versus simple, then the sample size and to be taken is okay. So we need to determine the sample size. So we have given that null and alternate hypothesis test. Now for now recall this the standard result, which is the null hypothesis theta is equal to theta naught against theta is equal to theta 1. When theta 1 is greater than theta naught, then in that case critical region is given by x bar greater than k. Okay, if it is less than, then critical region is given by x bar less than k. So our condition is, because 100 is greater than 19 means theta 1 greater than theta naught, so our critical region will be x bar greater than k. So we also given that probability of type 1 error and type 2 error is 0.05 and 0.01 respectively. Then let's consider first equation and solve this. So x belongs to omega means critical region is x bar greater than k, means probability that x bar greater than k under h0 means when theta is equal to 90. Okay, it is given that 0.05. So now to determine the value of k, we need to find the distribution of x bar. So recall this result: if x1 is to xn is following a normal with the mean mu and sigma square, then their sample mean means x bar will follow a normal distribution with mean mu and sigma square by n. So we will be using this result. So this is following normal theta 100, then x bar will follow a normal distribution with mean theta and variance 100 by n. So under our theta, under alternative hypothesis under null hypothesis our theta is equal to 90. So under null hypothesis means under h0 theta will be about 90. Now this means x bar will follow a normal distribution with 90 100 by n. Now this means x bar minus 90 divided by standard deviation means 10 by under root n will follow a standard normal distribution. Okay, means x bar minus mu sigma under root n will follow a standard normal distribution, so that we are using here. Okay, so let's use this and to find the value of k, means x bar minus 90 divided by 10 by under root n. Similarly k minus 90 divided by 10 under root n, probability that this will be 0.05. now this will be z, and under root n k minus 90 divided by 10 will be 0.05. now how to determine this value? So it is given that this area is 0.05. so means what 0.05 area in the right tail will be this area. Okay, now how to determine this value? Because this value is nothing but this point. Okay, so we can determine by using the confidence interval. Okay, so if this is 0.05, then this will be 0.05. okay, now determine this value. So this value will be 1 minus add these two means 0.10 and subtract 0.90 means this value is 0.90. means in 90, now recall the standard table of the confidence interval. So for the 90% confidence interval, the z value is 1.645. okay, so this value will be 1.645. so let's equate it. So under root n k minus 90 divided by 10 is equal to 1.645. now we need to find the value of under root n, so we need to eliminate k. So for that, let's equate it with k. Let's write this equation in terms of k. So multiply 10 with 1.645, 16.45, then by under root n, then this will be plus 90. So this is our equation 1. now similarly solve this. So means probability that x belongs to under omega complement means the acceptance region. Critical region is x bar greater than k, acceptance region will be x bar less than k. Under h1 means the alternative hypothesis means theta is equal to 100 is given to be 0.01. Now what we have done earlier, okay, we need to do this, repeat the same process. So here theta is equal to 90 and here the theta is equal to 100, means we just need to replace and 90 by 100, okay, and we need to find the value of k here. So under root means under root n x bar minus 100 divided by 10 under root n k minus 100 divided by 10 will be 0.01. This will be z under root k minus 100 divided by 10 is equal to 0.01. Now this is given to be 0.01. So under the standard normal distribution, this area is 0.01. Okay, so because it is less than side, that is why I taken the in the left hand side area. So now what is this value? This value is nothing but this point. Okay, now let's find using the similar way that we have using the confidence interval. So this value will also be 0.01 and this area will be 1 minus, add these two, 0.02 means 0.98. So for 98% confidence interval, z value is about 2.236. okay, so this value will be 2.236. okay, so here it is positive. okay, so but here it is less than sign, so we need to take this value. So this value is equal to minus 2.326. now let's equate it. Under root n k minus 100 divided by 10 is equal to minus 2.326. now find the value of k by this equation. Multiply 10 with this, so minus 23.26 divided by under root n plus 100. So we have two equations. Now equate these equations, okay, and find the value of n root n, find the value of n. So 16.45 under root n plus 90 is equal to minus 23.26 under root n plus 100. Now 100 minus 90 is equal to 10. This will add okay, under root n will be 5 11 हासिल 1 7 and 9 and 3. now under root n will be this divided by 10, okay, then 3.971. now square root side and will be 3.971 square. Now see, this is very close to 4. okay, so our answer will be about 15.99 something maybe. So because 4 square is 16 and this is close to 3.9, this is close to 4, so our answer will be 15.9. but we don't take the sample size in fraction, so we take the next term, so then our sample size will be 16. okay, so for question number 40, option C is correct.